We have a stick. Imagine you have a stick that is 150 million kilometers long. It stretches from your backyard all the way to the burning surface of the sun. The stick is perfectly straight and extremely rigid. Humans hate limits. But the universe has a speed limit. We all know this. 300,000 kilometers per second. We want to go faster. We want to be instant. Since we can't travel faster than light, we love to look for loopholes. Now, here is the question that breaks physics. If you push the handle on Earth, does the other end poke the sun instantly? Intuition screams yes. It's one object. If you move the start, the end must move too. If this is true, you have just created a communication device faster than light. You could send signals instantly across the galaxy. But as always, the universe is a party pooper. Mocking Einstein as you do it. Not only is the answer no, but the reason why reveals a terrifying truth about your reality. Why solidity is a lie. To understand why our superstick fails, we need to destroy the concept of solidity. You think the stick is solid because it feels hard. But if you zoom in, deep down to the atomic level, you see that the stick is mostly empty void. If an atom were the size of a football stadium, the nucleus would be a marble in the center, and the electrons would be tiny flies in the highest stands. Everything in between is nothing. So what holds the stick together? Forces, specifically electromagnetic forces. The atoms are not touching, they are trapped in a web of invisible springs. Imagine the stick not as steel, but as a billion-kilometer-long mattress spring. When you push the handle, you are not moving the stick. You are only moving the first few atoms in your hand. These atoms move forward, getting uncomfortably close to their neighbors. The electromagnetic force pushes back, shoving the second layer of atoms forward. This chain reaction creates a pulse, a compression wave, and this wave takes time to travel. We have a name for the speed of this wave. In air, you call it sound. Inside a solid object, it is still the speed of sound. In a steel stick, this wave travels at about 6 kilometers per second, which sounds fast. It is Mach 17. But space is big, really big. At this speed, your push will take a very long time to reach the sun. Light gets there in 8 minutes. Your push, it will take 290 days. You would be pushing for nearly a year before the sun even felt a tickle. By the time the sun moves, you might have forgotten why you poked it in the first place. Okay, you say. Stupid steel. I will build a stick made of diamond, or better yet, a magical material that is perfectly rigid. A material where the atoms are so tightly bound they have zero wiggle room. If it can't compress, the wave must be instant, right? This is where we run into Einstein again. The laws of physics strictly forbid a perfectly rigid body. It is not just an engineering problem. It is a fundamental impossibility. For an object to be perfectly rigid, the information, "I am being pushed," would have to travel instantly from one end to the other. This means information traveling faster than light. If you could send information instantly, you break causality. Depending on who is watching, you could create scenarios where the sun moves before you push the stick. Effect preceding cause. The universe collapses into a paradox. To prevent this, the cosmos enforces elasticity. Even if you made a stick out of neutron star matter, the densest stuff in the universe, it would still be floppy. In this super-dense material, the speed of sound might reach 10% or 20% of the speed of light. But never enough, never instant. The wave must travel. This leads to a somewhat lonely realization. We are all trapped in our own bubbles of now. This delay doesn't just apply to space sticks, it applies to you. When you touch the table in front of you, you don't feel it instantly. The compression wave has to travel through your skin. Then the electrical signal has to crawl up your nerves to your brain. You are living in the past. Your consciousness is always lagging behind reality by a few milliseconds. You have never touched anything in the present. Even in a hug, there is a delay and a gap. We can never truly close the distance. Our electrons repel each other with such force that we never actually touch anything. We are always hovering, separated by the speed of sound and light. This delay is not just about sticks. It rules gravity, too. If a cosmic wizard stole the sun right now, Earth would continue to orbit an empty spot for 8 minutes. We would feel the warmth and see the light of a ghost. Gravity, magnetism, light, your poke, they all obey the same speed limit. Which begs the question, why this specific speed? Why not instant? Why not slower? Some physicists think this speed is the refresh rate of our reality, the maximum processing speed of the universe's computer. If we went faster, the simulation might crash. However, there is something that breaks this rule: space itself. While you cannot move through space faster than light, space itself can expand faster than light. Right now, distant galaxies are being pushed away from us so fast that their light will never reach us. They are exiting our bubble of reality forever. We are slowly becoming more alone. And then there are black holes, places where space falls inward so fast that not even light can climb out. If you poked a stick into a black hole, would the other end feel it? Or does time stop completely? The universe is full of these terrifying edges, limits where our understanding of physics breaks down into nonsense. We promise to explore these nightmares in future videos. But for now, back to your stick. You cannot poke the sun instantly. You have to wait. And maybe that is beautiful. The delay allows for structure. It prevents everything from happening all at once in a chaotic scream of noise. It gives us time to exist. Thanks for watching.